Hi, welcome to my review of square root radicals, part 1. This review is on the videos from 1 to 26 on the square root radicals. And what I do with a review is I treat it as a quiz to see how well you know the unit on square root radicals. So if you reviewed all the videos from 1 to 26, then this is a good test to see how you're going to do. And here we go. Notice also before I start that this is page 1 of 4. There are 3 more pages after this. So what you can do is pause the video, get 3 blank sheets, and work out the answers to each one and record if you have it right or wrong, and get the total on each page. As in this page is a 10. Next page is a 9 total. The next page has a 9 total, and you can total it all up to see what you get out of 28. Then you can divide your denominator into your numerator, change it to a decimal, move a decimal 2 places to the right to get a percentage, and see how well you know the unit on square root radicals. Here we go. Remember, treat it as a quiz, so pause your video, work out the answer, and press playback to see how well you do. Here we go. Do that for each page, 3 pages. Here we go. Number 1, find the principal square root of 24 plus 8 divided by 4, subtract 5 times 2. Well, what we're doing here is we're doing PEMDAS, P-E-M-D-A-S, and we have no brackets, we have no exponents, so we do multiplication and division, either or from left to right. So that's a 24 plus 8 divided by 4 is 2, and 5 times 2 is 10. So that's the work that works out to be altogether 26. That works out to be a 16. So the principal square root of 16 is 4. 4 is the correct answer. Give yourself 1 mark if you're right. The principal square root means it's the positive square root. Number 2, root 19 lies between what 2 integers? Well, root 19 is between the perfect squares. The upper one is a 25, and the lower one is a 16. So root 19 is somewhere between root 16 and root 25. So that means it lies between 4 and 5. Give yourself a mark if you're correct. Number 3, simplify. And again, we look at PEMDAS, P-E-M-D-A-S, or BEDMAS. And we have, if you can see, I have a bracket here. So let's work out that bracket first. 4 times 2, subtract. That's a 6 squared. So I did inside of the bracket first. Now I have to do my exponent. So I do my exponent, 4 times 2 minus 36. Oh, notice. Now I just noticed that this is 8 minus 36 is negative. But I said 4 minus 2, and that's a 2. So again, be careful. 2 squared is a 4. Okay, now we're on the right track. And let's go up here. So I have the exponent done. Now I got to do multiplication division. So that's 4 times 2 is 8. And 8 minus 4 is 4. And the square root of 4 is 2. So notice I just made one little error there. Sorry about that. But I follow the PEMDAS through this. And very important to do the order of operations. Number 4, simplify as a radical, root 18. Well, the root of 18 is a 9 times 2, and the square root of 9 is 3, so we get a 3 root 2. Another mark. Express 4 root 3 as an entire radical. Well, an entire radical, this is a mixed radical, so because there's a 4 there, then it must have been a 16 inside, because the square root of 16 is 4. So that's, if the 4 is out here, it's a 16 underneath the root. And 16 times 3 is 48. So the answer is the root of 48. Another mark. Simplify as a radical. Well, we have it all written out into prime factorization in order. So for every two factors that are the same, we take one of them out. And we got 2 3s, so we take one of them out. And what's left inside is a 2 times 5. We can't take that 2 out of 5 because there's only one of them. So 2 times 3 is 6, and 2 times 5 is 10. So that's fully simplified. Another mark. Simplify as a radical. Now, what happens here? So I have to go with 100, or let's go. Notice it's even, so because it's even, I'm going to divide by 2. So that's a 7, 2, 6. And it's even again, so I'm dividing by 2. 2 and a 7 goes 3. That's a 12, that's a 6, and a 3. I see all 3s, and notice they add up to 12. 12 is a multiple of 3, so I divide by 3. 3 into 3 goes once. 3 into 6 goes 2. 3 into 3 goes once. And I got 121. 121 is 11 times 11. So that breaks down into 2, 2. There's 2 2s. There's 1 3. And there's 2 11s. So you can't, probably you wouldn't be able to get the greatest perfect square of this as a factor. So breaking it down by dividing with the divisibility rules of 2 and 3 and 5, etc., etc. So I have a 2. I have 11 because there's 2 of them. And there's a 3 left over. So that works out to be 22 root 3. Give yourself a mark. But notice, I always work with even numbers. When it's not even, then I see if a 3 works. If a 3 don't work, I think about a 5, and etc., etc., 10, etc. Think about the prime numbers when you do visibility. Number 8, which radical is like 4 square root 3? Well, it's got to be a square root, so that's a 6, so that's not right. That's a cube root, so that's not right. So it has to be one of these two. So because it's a square root of 3, it can't be that one. So the right answer is -7 root 3, square root of 3, like radical. Did you get it right? Give yourself a mark. Now, I want to simplify this, and I look through, and I see all 2's, but I see a double negatives. The first thing I do is make my double negatives positive. Now, because I have double negatives gone to plus, they're all like radicals, so they're all going to become a root 2. So -6 plus 4 is -2. -2 plus 5 is 3. So there's a 3 root 2. Number 10, simplify. And I have root 5, root 7, root 5, root 7. So I'm going to group my like terms. There they are. There's my like terms. Root 5's go together. Root 7's go together. So 6 root 5 minus 2 root 5 is a 4 root 5. And 4 root 7 subtract, that's a 1. Put a 1 there. That's a root 7. So 4 minus 1 is 3. That's a plus 3 root 7. If you have that answer, give yourself a mark. Total of your page and see what you have out of 10. Hopefully you're doing okay. Everything is going great. Number 11, find the perimeter of the triangle. Perimeter means the distance around. So I see 2 marks, as in, so because those are marked with 1 stroke, that means if that's 6 root 2, this is 6 root 2. And so the perimeter is the distance around, so the sum of all the sides. So it's 6 root 2, add on 6 root 2, add on 5 root 3. And when you add like terms, so those two are the same. So that's a 12 root 2 plus 5 root 3. Give yourself another mark if you're right. And number 12, simplify. When you're doing radicals, you should always simplify the inside of the radical if you can. So 20 is 4 times 5, a perfect square. So that's a 2 root 5. Oh, I forgot to do my double negatives. 2 negatives make a positive. So done. Now 27 is a 9 times 3. So that's 3 root 3. 45 is 9 times 5 as a perfect square factor. Square root of 9 is 3, so it's 3 root 5. And 300 is 100 times 3, so that becomes 10 root 3. And we group the like terms, so we get 2 root 5, add on 3 root 5, and we got a 3 root 3, and a minus 10 root 3. Notice none of these signs are changing because I'm only regrouping them. I'm not transposing them across the equal sign. So the final answer here, 2 plus 3 is 5, so that's 5 root 5. And the answer here is a negative 7 root 3. So if you have that answer, give yourself 1 mark. 13, simplify. 5 times the square root of 24. Remember, we should always simplify the square root of 24 like the square root of 20 and 27, these 4 up here. So that's a 4 times 6. So the square root of 24 is a 2 root 6. It's simplified. And now we multiply. 5 times 2 is 10, root 6. Remember, the 5 does not multiply by the root 6. You can only multiply 2 numbers at the same time. So 5 times 2 gives you 10, so it's 10 root 6. Another mark if you're right. 14, simplify. So we have PEMDAS, we have these brackets are simplified. We have no exponents. We have to multiply these two and these two first before we subtract. 16, 8 times 2 is 16 root 5. And 1/3 of 3, 3's cancel. And so I get a negative root 5. And when I subtract like terms, I have root 5. So 16 subtract 1, that's a 1 there. So that gives me 15 root 5, final answer. Another mark. Number 15, we're going to simplify this. So the root of 28 and the root of 63, looks like we probably can simplify it. Let's see if we can. 28 is a 4 times a 7. So that's a 2 root 7 plus 5, 63. 7, 9. 9 times 7 is 63. So that's a 3 root 7. That's a root 7 there. And now we have to multiply these two before we add. That's a negative 6 root 7 and a plus 15 root 7. Again, the 5 is multiplied by the 3 first. We get 15, and we can't multiply it by root 7. And remember, a root, you can only multiply a root by a root. You can't multiply like 8 times root 2, which is 8 root 2. So like terms is root 7. Negative 6 and 15 is plus 9. So 9 root 7, give yourself a mark. Simplify. I'm going to do this one 2 ways. Most students probably would say 6 times 15 makes 90. And 90 is 9 times 10. So that becomes 3 root 10. That's okay, because you can recognize that 90 got a perfect square factor. The highest one is 9. But another way to do it, think of this way. When you multiply, you make the numbers bigger. So if you go 6 like that, and then you break it down, 6 is 2 times 3, and 15 is 3 times 5. Breaking it right down means you won't get a big number. This is a 90, like I said, you recognize 9 times 10. But when you do it this way, break it right down, you pick out the double factors. So there's 2 3's there, so you write down a 3. The 2 and the 5 can't come out, so that's a 10. So 2 ways to do it, your choice. Just like making sure. Now, what happens here? Now, the product of these, imagine multiplying 21 by 14 and trying to break it down. What I'm going to do is this negative times a negative is positive. 5 times 4 is 20. So let's write that 20 right there. But instead of multiplying these together, why don't we put 21 as 3 times 7 and put 14 as 2 times 7. There's still a product of 21 times 14 there, but it's split. It's broken up. Makes it is easier to recognize. Let's see what happens here. By not multiplying it out and getting a big number, breaking it down, I see 2 7s. So those 2 7s, I take one out. And I get 2 times 3, 6 left. So when I do that, 20 times 7 is 140 root 6. So when the numbers are large, it's easier to break them down into prime factorizations first, and then you can pick out the doubles. 18, simplify. That's a negative 3 root 2 times negative 3 root 2. When you square, you multiply by itself. Negative times negative is positive. 3 times 3 is 9. Root 2 times root 2 is root 4, which is 2. So that gives you 18. If you have 18, give yourself a mark. Number 19, simplify. And again, think about PEMDAS, or bed mass. We have, can we simplify inside root 6, root 2, root 3, no. So we can't simplify. We have to do the exponent. So root 7 squared is root 7 times root 7. So that's a 7. So I have my exponent done. Now I'm only doing one step at a time. Now we have a 7, and I will do multiplication division. So I'll do the multiplication on these two. Here we go. So that's positive. 2 times 4 is 8. Root 3 times root 2 is root 6. And negative 3 times 4 root 6 is a negative 12 root 6. Remember, the negative 3 is multiplied by the 4 to get the negative 12 with a root 6. Add up the like terms, 7. No more terms like it. And 8 subtract 12 is a negative 4. So if I want, I can go plus and negative, but I got a plus there. So I'll just do this for a second. But that's really 7 subtract 4 root 6. I put the plus in there too quick. So there's the correct answer. And give yourself a mark. Add all the page out to see, and put your total at the bottom. Let's continue. How well are you doing? Hopefully good. Did you review all my videos? Is everything going well? Hopefully. Find the area as a radical in simplest form. Okay, it's the area of a triangle. The area of a triangle is half the base times the height. So I have a half. The base is 8 root 10. And the height is root 5. So we can multiply a half by 8 root 10. So that gives us, we cancel that, it gives us 4. So that's 4. And root 10 times root 5 is root 50. And root 50 is 25 times 2. So that's 5 root 2. And the final answer, 4 times 5 root 2 is 20 root 2. Give yourself a mark if you're right. Notice what, any error here, you won't get a mark. But if you made an, hopefully you didn't make an error and everything went well. Notice a half of 8 is 4. And I cancel it. You can take a half of 8, get 4. 2 and 8 goes 4 with fractions. Number 21, simplify. We have brackets. Let's see. We can't simplify the inside of here. So we have to multiply 4 by 2 to get 8. And 4 by 3 root 2 to get 12 root 2. And a negative, I treat it as a negative 2 times that. So I treat it as a negative 2 times 1 is negative 2. Negative times negative, positive 8 root 2. And you could, if you want, because this is subtraction here, add on the opposite like that. And multiply negative 2 by both of those, you get the same thing. Now group your like terms. There they are. 2 goes with the 8, the root 12, and the root 12 root 2 and 8 root 2. Notice I didn't change the signs. Add 6, and that's a 20 root 2. Give yourself a mark if you're okay. Notice that was a subtraction sign. I made it plus a negative, or just a negative 2 on straight multiplied by the inside. Simplify. Again, we had the same thing. We have PEMDAS. We can't simplify root 7 or root 5 or root 7 or this root 5. We can't simplify the inside, so we have no brackets. We have no exponents, so we have to multiply root 5 by both of these. So root 5 times negative 3 is a negative 3 root 5. And root 5 times 2 root 7 is 2 root 35. That's a 2 there. Just a little slip. Now again, we have a negative times a positive, so it's a negative 4 root 7. And negative 2 root 7 times negative 3 root 5 is a positive. 2 times 3 is 6. Root 7 times root 5 is root 35. We group our like terms. Let's see, like terms. We have a 3 root 5. We have no more like it. We have 2 root 35. We have a 6 root 35 that's like it, like terms. And we have a 4 root 7. So note, now this there's no this stays like that because there's no other term like it. This is like terms, so 2 plus 6 is 8. And 4 root 7. Can't change it because there's no more like it. If you have this answer, give yourself a mark. 23, we're adding these terms. So when you add, you don't change the sign. So that's a 9 plus 10 root 6. When you add, that's a negative 7 plus root 6. Adding, you do not, when you remove the bracket, you do not change the negative 7 or the plus root 6. Group like terms. So we're putting the 7 and the 9 together, 10 root 6 plus root 6. And when you add them up, you get 9 subtract 7 is a 2, 10, and that's a 1 there. 10 plus 1 is 11, so it's 11 root 6 is your final answer. Number 24, the opposite of 4 plus 3 root 11. The opposite is you change both sides. The opposite, you change both sides. With a conjugate, you only change the second one. But with the opposites, if you add these together, you should get 0. If you have that, give yourself a mark. Now, we're subtracting. A little trick in subtracting, when you're subtracting two terms, you can put a 1 there and a 1 there. So 1 times 8 is 8. 1 times negative 4 root 3, negative 4 root 3. Negative 1 times 9 is negative 9. Negative 1 times negative 7 root 3, positive 7 root 3. Group your like terms. And 8 minus 9 is negative 1. And a negative 4 and 7 is a positive 3 root 3. And if you didn't want to write this step, you wanted to do it fast, that's all you say is 8 subtract 9 is negative 1, and negative 4 root 3 plus 7 root 3. So you didn't have to do this if you know what you're doing. You get 1 mark. And PEMDAS, we have to simplify our brackets, our square roots if we can. Okay, looks like the square root of 4 is 2. 50 is 25 times 2, so that's 5 root 2. 8 is 4 times 2, so that's a negative 2 root 2. 49, square root of 49 is 7. So I have all the square roots simplified. Now I'm subtracting again. So again, I'm just going to do this for a second. 2 plus 5 root 2, subtract. Subtract means you add on the opposite. So that's subtract. The opposite of a negative is a positive 2 root 2. And the opposite of plus 7 is a minus 7. Or, go back and do what I said. You put a 1 here and a 1 here. So 1 times these 2 will give me these. And a negative 1 times a negative will give me a positive. And a negative 1 times a positive will give me negative. And we group like terms, 2 and a 7. 5 root 2 plus 2 root 2, and that comes out to be a negative 5 plus 7 root 2. Final answer. And number 27, we're multiplying. So we're multiplying by FOIL as a binomial times a binomial. So the first 6 times negative 1 is negative 6. 6 times 3 root 2, that's first. Outside is plus 18 root 2. Inside is root 2 times negative 1 is a negative root 2. And root 2 times 3 root 2. 3 times 1 is 3. Root 2 times root 2 is 2. So root 2 times root 2 is 2. 3 times 2 gives me 6. And they cancel. And 18 subtract 1 is 17 root 2 is your final answer. And number 28, I'm going to do this in 2 ways. FOIL method. First, 4 times 4 is 16. Outside, 4 times root 3, 4 root 3. Inside, negative root 3 times 4, negative 4 root 3. And last, negative root 3 times root 3 is a negative 3. Square root of 9, which is 3. And I have like terms, so I have 16 minus 3 and 4 root 3 subtract 4 root 3. I should cancel these, and so the final answer, they're gone, and that gives me a 13 as my final answer. Another way to do this, but it's in the next review, these are 2 conjugates of each other because the middle sign change. You could, if you notice it, you could go 4 squared subtract root 3 squared. Because they're conjugates, which means you change the last sign, that's the same 2 terms with a minus and a plus. You square the 4 minus the square root of root 3. That's a 16 minus 3, and you get a 13 right away. So you can either FOIL it to work it out, or you can do that, your choice. And that brings us to the end. So we got 9 on that page. We have 9 on the next page. We have 10 on the next page. And you go back to the first page, and there it is. If you total it up, put the mark at a 28, divide 28 into the numerator, get a decimal, move it 2 places to the right, and get your percentage. Hope you did well on the video review of the radical review on videos 1 to 26. If you like my video, click the like button, the subscribe button, and the notification bell, because there are more videos coming your way. Also visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel. Hope you enjoyed my video. Thank you very much. Bye-bye.